we'll be going through surface area set 22. So with surface area, what you have to revisit is your area formulas. So for example, look at the triangle over here. To find the area of the triangle, what we do is we multiply the base by the height and then divide it by 2. So it's half base times height. So just revisit all the area formulas just to get an understanding of how these formulas are going to be working together to find the surface area of an object. Okay, so over here we've got the rectangle, length times the width or the breadth. For a trapezium, remember it's half height brackets a plus b being the side length. Okay. For the circle, it's an easy one. It's pi r squared, r being half the diameter. This is a very important one, Pythagoras theorem. When you're working with right angle triangles, what you need to do is you need to find out what the missing height is. So for example, we've only got C and A. We won't be able to find out what the area of this triangle is. So what we will need to do is find out what B is for the height. Or if we had C and B, we will need to find out what A is to find out the area of this triangle. And to find out what the missing side length is, what we use is C squared is equal to A squared and B squared. But this only works for right angle triangles. So always make sure all these triangles are right angled if you're going to apply Pythagoras theorem. Okay, let's get going. So a rectangular prism. So with a rectangular prism, there are 6 surfaces. So you got the top and the bottom, front and back, and left and right. Okay. What I would recommend doing is calculate the area of each side separately and then add them up. With a rectangular prism, there are 2 sides that are similar, so you can just find one side, times it by 2. Okay, for example, the front side is 4 times 3, which is 12, times it by 2, we have 24. We've got the left and right sides, so 8 times 3 is 24, times it by 2, we've got 48. And then we've got 8 times 4, which is 32, times it by 2, we've got 64. Then we add all them up, so 64 plus 48 plus 24 gives us 136. Okay. This is a different way to do it, but it takes a little bit of time. It's easier to just have a look at the object itself and figure out what it is, because thinking about the net of an object will take a lot of time during an exam question. So what I would just recommend is that look at the object as it's given to you and try to figure out what the sides are and then what the individual surface area is for each side, and then add them up at the end. Okay, let's have a look at all the other prisms other than rectangular prisms. So with triangular prisms, they're made up of 2 identical triangles and 3 differently sized rectangles. Okay, the 2 identical triangles are at the front, so we've got a triangle with a base of 4 and a height of 3 centimeters, and we've got 3 other differently sized rectangles, 7 times 6, and we've got another one 7 times 5, and we've got another one 7 times 4 at the bottom. Okay, to find out the surface area of this triangular prism, what we would do is find out the surface area of the triangle at the front, which is 4 times 3 divided by 2, which is 6. So we times it by 2 to get the back triangle as well. Okay, now we look at the rectangle over here, the one on the right hand side, which is 6 times 7, which gives us 42, and the one on the left hand side, 7 times 5, because the width over here is 5, the length is 7, so which gives us 35. And we look at the bottom, which is 4 times 7, which gives us 28. So we add them all up, which should give us 117 square centimeters. Always remember the units. Okay, if you don't give the units, it's wrong, but in an exam question it'll probably be multiple choice, so you don't have to worry about the units. But whenever you're doing short answer questions, always remember what the units are. So we've got a trapezoidal prism. So with the trapezoidal prism, we calculate the area of the trapezium at the front and the back as well, because those are two identical trapeziums, so we don't have to do it separately. It's just the same 1 times by 2. To find out what the area of the trapezium at the front is, what we need to do is calculate the area, find the height, which is 5, and then the side lengths, which are 14 and 12. Okay, so we've got half times height, a plus b. So a plus b gives us 26. 26 times the height is 5. So 26 times 5 gives us, let's see, 5 times 5. 150. Let me have a look. So we've got 26 times by, sorry, it's 26 times by 5, so it's 130, and we divide it by 2 because it's half times height plus a plus b. So we get 130 divided by 3, which is 65. That's the front trapezium. The back trapezium will be 65 as well, so we just add the 65s together to get us 130. Okay, and then we have a look at all the rectangles. So this one's 48. The one on the other side will be 7 times 12. Sorry, no, 7 times 8, because it's 7 and the length is 8, so which gives us 56. The rectangle on the top is 12 times 8, which is 96. Whoops. And the rectangle at the bottom is 14 times 8, which is 112. We can add them all up, add the trapeziums up, so that trapeziums gives us 130. Add all these numbers up, which should give us 442 square centimeters. Okay. Okay, we have a look at applying Pythagoras theorem to find the surface area. So here we don't know what the side length of this length is, because we need that length to find out what the area of the triangle is, because that's the height of the triangle. We've got the base, we're looking for the height. So we just need to apply Pythagoras theorem. If you remember your Pythagoras triads, you know that 10, 6, and 4 go together. 8 go together, sorry. 10, 6, and 8 go together. So we know that this missing side is 8 centimeters. And now what we need to do is just find out the area of this triangle here. Now we know that the base is 6, the height is 8, so the area of the triangle at the front gives us 24 square centimeters. So the back triangle is also the same because it's identical, which gives us 48 in total, 48 square centimeters. Then we just calculate the areas of the 3 different sized rectangles. So the one at the front gives us, sorry, on the right hand side gives us 120. The one at the back should give us 8 times 12, which is 96. And then the rectangle at the bottom is 6 times 12, which gives us 72. We just add these all up. Remember, these are all square centimeters. I'm not gonna, okay, that's fine. We can put the units there as well, but we can just add these all up to get 336 square centimeters. Okay, and that's our answer. This is a very important one, surface area of a cylinder. Cylinders have 2 circles and a curved surface, okay, which makes the cylinder roll. So when we're looking at the curved surface, have a look over here. The length of the rectangle, if we just open up a cylinder, the net of the cylinder will look like this, okay? If you were to open up the cylinder and have a look at the length of the rectangle of the curved surface, it would give us 2 pi r. Why does it give us 2 pi r? It gives us 2 pi r because the circle has been opened up here, okay? If you were to open up the circle from this end towards this way and this end towards this way, it will give us the circumference of the circle. That's the length of the rectangle. The circumference of the circle is given by 2 pi r. That's why that's the rectangle of the, length of the rectangle. Same goes for this one because it goes a radius that way, a radius that way, sorry, and it's just 2 pi r because it's the circumference. When we open up the circle, it gives us the perimeter of the circle. If we open up the circle over here, it just gives us the circumference of the circle, which is 2 pi r. And the height is just height of the cylinder, which is the width of the rectangle over here. And we can show this surface area of a cylinder formula this way. So to find out the rectangle's area, what we do is length times the width, 2 pi r times h. To find out the area of the circle, we do pi r squared. So we do the same thing for this circle as well, so pi r squared. So it gives us 2 pi r squared, 2 pi r squared, okay? Because we have 2 circles and we're just looking for the area of those 2 circles. Area of one circle is pi r squared. The area of 2 circles would give us 2 pi r squared. Now we need to put these 2 expressions together. So the first expression is the surface area of the rectangle, the curved surface which has been flattened, which gives us 2 pi r times the height, and then we add it to this over here, okay, which is 2 pi r squared, 2 areas of the circle, of 2 circles, okay. So this is our surface of a cylinder formula. So always remember this formula. This formula is very useful for you, okay. You guys can have a look at the example over here and go through it by yourself. We can move on to questions now. Whoops. Okay. Whoops, there we go. Just adjust it a little bit. Okay, let's have a look at the questions now. Surface area set 22. Let's do question 1C first. Let's start with that one. Okay, blue 1C. We'll do 1D, 1I, and 1J. Okay. All right. With 1C, how would we start it? To start it, we need to figure out how many different distinct shape faces are there on this shape. Okay, we've got one here, one here, one here. There's one at the left hand side here, so that's 4. There's one at the back, 5. There's one over here and one upwards. So there's 7 distinct faces that we have to look for. Okay, areas that we have to look for. We know that this length over here will be the same as the bottom length because it's just the same length over here, which is over here. So we know that this is, we can expand this, sorry, zoom in a little bit, 1.1, okay? Now that we know that this is 1.1, we also know that this is also 1.1, that side, okay? Let's try to figure out what these lengths are. We know that this is 1.4 and this is 1 meter. So the missing length over here is 0.4. Okay? And we know that this length is 1.3 and this is 1 meter. So the missing length over here is 0.3. You can put meters. Okay? So that's what we're looking for. Alrighty, now that we have all the information that we need, we can just start calculating the surface areas of each side, each face. Okay, let's have a look at the top one. That's 1.3 times by 1.1. Okay, we'll try to calculate that later. Let's have a look at the one on the side over here, on the right hand side. That's 1.1 times by 1. I'll write that down as well. 1.1 times by 1. Let's have a look at the side on the left hand side, this one. That would be 1.4 times by 1.1. We've also got a side over here. Let me just show you what the side is. Okay, we've got a side over here, right? What do you think that side would be? That would be 1.1 times by 1.4, 0.4. Okay, go find that side as well. And what else do we got? We've got this side underneath here. What do you think that would be? That would be 1.1 times 0.3. How many sides have we got now? We've got 1, 2, 3, 4, 5. Okay. Now, when we're looking at the face of the front, we can't really find the area of a shape like this, because we'll have to first divide it up into two distinct shapes like that. Okay, now we can find out what the area of the shape is. So what's the area of this shape over here? It will be 1.4 times by 1, which is 1.4. Okay, we'll just put it over here, 1.4 times by 1, and we'll need to times it by 2, because there are two sides like that, because at the back we've also got a shape just like this, times it by 2. Okay, now we've also got this little rectangle over here. I'll color it in green so that you guys can understand what I'm talking about. Okay, now for this green one, what's the area of that one? To find that one, we need to times this length over here, the 0.3 length, by the width, which is 1 meter. So we do 0.3 times by 1 times by 2, because there are two sides at the back as well. Now let's calculate what all these calculations give us. So 1.3 times 1.1 gives us 1.43. 1.1 times 1.1, so 1.1 times 1 gives us 1.1. 1.4 times 1.1 gives us 1.54. And then we have 1.1 times 0.4, sorry, not 0.8. I made a mistake. That should be 0.4, which gives us 0.44, because it's essentially 11 times 4, but with 2 decimal places. Okay, so what's this one? 1.1 times 0.3, it's 11 times 3, but with 2 decimal places, which gives us 0.33. Now we've got 1.4 times 2, which is 2.8, and then we've got 0.3 times 2, which is 0.6. Now when we add all these up, this would give us, let's have a look, add all these up, 4 over here, 3 goes over here, and 9 over here. Okay, it should give us 9.34. Oops, just blacked out for a minute. Okay, there we go, 9.34. What are the units? Square meters. Okay, that's the answer. Let's move on. Let's have a look at the shape in question D. So it's a trapezoid prism. Let's have a look at the trapezium at the front. Let's find out the area of the trapezium. We've got the two side lengths, which is 23 and 13, so we'll put that in brackets, 23 and 13, times by the height, which is 19. I'll put 19 over here, whoops. 19, and divided by 2, so times by half. Okay, and remember there are two trapezoids like that, trapeziums like that, so we times it by 2 as well. Now let's have a look at this rectangle over here. It's 21 times 12, so we just do 21 times 12, leave it as that. And we've got a rectangle at the top, which is 13 times 12, we can write it as that, 13 times 12. What else do we have? It's 12 because it's the same length over here. Okay. What else do we have? We've got the bottom rectangle, which is 23 times 12. And then we've got a rectangle at the left hand side, which is, what's that? So that's 19 times 12. Okay. Okay, now that we have all these numbers, we'll just need to calculate them. Okay, 23 plus 13 gives us 36. So we do 36 times 19 times 2. We do 36 times 19 times 2 times half. So 2 times half is just 1. So we just need to do 36 times 19, which gives us 684. I'll just write that down over here. 684. What's 21 times 12? 21 times 12 gives us 252. And 13 times 12. That should give us 156. And then we have 23 times 12. That gives us 276. And we've got 19 times 12, which gives us 228. And all we need to do is add all these numbers up, okay? So 4 plus 2 plus 12 gives us 18. 18 plus 8 gives us 6. Got 5, 16, so 9 over here, 5, and 1. Okay, so the answer should give us 1,596 square meters. What I want you guys to do is do this by yourself and see if you get the same answer. Okay, let's go into the other question. Zoomed out a little bit too much. Okay, there we go. Question I. We've got a shape that looks like a cheese. What we need to do is find out the different sides. Okay, so this side will be 3.8 times 5, so we can write that over here, 3.8 times 5. And this rectangle will be 6.8 times 3.8. Okay, and there's another rectangle at the back, which will be 9.7 times 3.8. 9.7 times, 3.8. And then we've got the triangle on top. So the triangle on top gives us 9.7, which is the base, and the height is 3.3. We do 9.7 times 3.3 times by half, then times by 2, because there are two triangles just like that. Okay, what I want you guys to do is calculate this all by yourself and see if you get the answer. Okay, so the answer is 113 and 71 square centimeters. Okay, 113.71 square centimeters. Okay, I want you guys to calculate the multiplications and add them up to see if you get 113.71. Let's move on to the cylinder. Okay, with the cylinder, remember the formula from before. It's 2 pi RH plus 2 pi r squared. Okay, that's a 2. Right, now what's our r? Our r will be half of this, because this is a diameter, and half of this will be the radius, which is 12. So we have 2 pi 12 times by, what's the height? 18. And we added 2 pi r squared. So we have 2 pi r squared. R squared will be 12 squared, which is 144. Okay, now I want you guys to use a calculator and find out what answer you get. So you can plug in pi as is and correct the answer to 2 decimal places. You guys can pause the video and put this in your calculator and see which answer you get, and see if you got the same answer as me. Okay, so the answer for J will be, if you put it in a calculator, 2,261 and 95 square centimeters. Okay, this should be your answer. See if you got it. If you didn't, see what went wrong and try it again. Alright, let's have a look at question 2 now. It's a bit hard. A ramp used for motorcycle stunts has the shape of a triangular prism as shown. Find the cost of painting the entire ramp if the paint costs $37 per square meter. Okay. First, what do we have to do? We need to find out what the distinct sides are. We've got this side over here, which would be 3.9 times 5.4. We've got the actual ramp side, which is 14.9 times 5.4. And what else do we have? Now we've got the bottom side. Even though we can't see it, they're saying that they're painting the entire ramp, so we'll probably need to calculate the area of that one as well. So to find out the area of that, we need to times the length by width by the length. The width is 5.4. What do you think the length is? Remember, this 14.5 is only up until this point. There's another 1.4 to add as well. So there's 14.5 plus 1.4, which gives us 15.9. Okay, that's the bottom part. Now let's look at the triangle. The triangle, we can't calculate the triangle without splitting it up. Or can we? We could. So if we were to find the area of the triangle, we have a look at the full base here, which is 15.9, and times it by the height, which is 3.6, and then divide it by 2. We'll do that. Let's do 15.9 because that's the full length of the base. 15.9 times by 3.6 times by half times by 2. Okay. Since why are we timesing it by 2? We're timesing it by 2 because there's another triangle same as that on the other side, an identical triangle. Okay, now let's find out what these numbers give us. 3.9 times 5.4 gives us 21.06. 14.9 times 5.4 gives us 52.2. Sorry, no. 14.9. That gives us 80.46. 80.46. And then we've got 15.9 times by 5.4. Let's do that. 15.9 times by 5.4, which gives us 85.86. And then lastly, we've got this triangle over here. So we've got 15.9 times by 3.6. And then half times 2 cancels out. So it gives us 57.24. Okay? 57.24. Okay, now let's add all these up. 57.24 plus 85.86 plus 80.46 plus 21.06, which gives us the total surface area to be 244.62 square meters. Okay, now what are they asking? What's the cost of painting the entire ramp if the paint costs $37 per square meter? So what we have to do is we need to times this surface area by 37. What's that? Let's do 244.62 times by 37, which gives us $9,050.94, and that's our answer. Okay, all right, let's move on to the carpet question. So look at the staircase over here. Each of the steps are to be carpeted, and we're supposed to find the area of what needs to be carpeted. Okay, so to find the area of this, we'll divide each step up into the front side and the top side. There's 4 front sides, so we have to times it by 4 first. Okay, and then the front side, we've got 1.8 meters as the length, and 18 centimeters is the width. So what we can do is we should convert all the units, all the lengths into the same units. Okay, we'll just convert everything into meters so that it's easier for us. So we have 4 times 1.8 times 0.18. That's our first equation. And then we've got the top sides. We've got 4 top sides, then times it by 1.8, and then times again by 0.23. What do we get when we calculate these numbers? So 4 times 1.8 times 0.18 gives us, so 4 times 1.8 times 0.18 gives us 1.296, and the second one gives us 4 times 1.8 times 0.23 gives us 1.656. When you add them all together, it gives us 5, 9, and then 2.952 square meters. Okay, that's our answer. And now they're asking if the carpet comes in a width of 1.8, find the length of the carpet so that the carpet can be laid without joints. What we need to do is just divide this number that we got by 1.8. So what's 2.952 divided by 1.8, which gives us, let's do it, gives us 1.64 meters. Okay, now let's have a look at C. The roller on an earth compactor is cylindrical in shape. Okay, if it's cylindrical in shape, this is the formula that we need to remember: 2 pi r h plus 2 pi r squared. It has a diameter of 84, so we know that the radius will be 42. We can already plug that in. Actually, wait, let's read the question first. And a width of 1.1. So the width of 1.1 would mean that the height will be 1.1, because the roller would look something like this. Okay. Find the area covered by the roller when it makes 1 revolution. Oh, okay. So they're asking for the area that will be covered by the roller. So when it rolls, it covers an area on the ground, right? They're asking how much area would it cover if it does 1 revolution. So they're just asking us the surface area of this curved surface of the cylinder. Remember from what we learned in the topic explanation, this first part of the surface area formula for a cylinder gives us the surface area of the curved surface, because when you lay out the net of a cylinder, when you flatten it out, that gives us, the curved surface gives us 2 pi r times by h. So we know that 2 pi is just 2 times pi, and then r is 84 divided by 2, which is 42, and then h is the width, which is 1.1. 1.1 meters is 110 centimeters. All right, what I want you guys to do is to put this in the calculator and see what you get. Okay, so when you put this in the calculator, you would get 29,013.16 square centimeters. Okay, because remember, we really need the units in these type of questions. 29,013.6 square centimeters, or if you were to convert all that into square meters, the answer will be 209.01, right? They're asking us for 2 decimal places, so 290. Hold on. If we were to convert square centimeters to square meters, what do? We need to divide it by 10,000, because 1 square centimeter is, sorry, no, other way around. 1 square meter is 10,000 square centimeters. Okay, so we divide this number by 10,000. 29,013.16 divided by 10,000 gives us 2.90 square meters. Okay, just jump the decimal place 4 times to the left, and this is our final answer. And that's it, guys. I want you to go through every single question and see how you go. The answers are in the next page. You can have a look at the answers over here. All right, good luck.